what is in for you is only alkanes and alkenes. Just now we talked about alkanes as a homologous series. So we go in depth into what the alkane homologous series is. So we are going to the definition again. Now you will see there is more. So where can you find alkenes? So alkenes can be found from the fractional distillation of petroleum. Petroleum means you can think of it as crude oil. Like the start of this whole series for organic chem, I talk about crude oil and then the different fractions of petroleum. So all the different fractions of petroleum are actually alkenes. So you have lubricating oil, you have diesel, you have petrol, all of these are alkenes. Okay, alkenes are a homologous series of saturated hydrocarbons. So keep this word in mind. It's a saturated hydrocarbon. Then it has a general formula for with CnH2n plus 2. So this formula is used to predict the formula for a certain alkane. Let's say I have a 5-carbon alkane. Then I'll ask you what is the formula for the 5-carbon alkane. So what you do is you take the
E5H12.
yes, like that. So it contains carbon single bonds, and everyone in the alkane homologous series will have similar chemical properties, like very much like everyone in the same group in the periodic table will have similar chemical properties. Then there's a gradual change in physical properties, which is also the same for those in the group in periodic table. Then the next one, they say they are hydrocarbons. Hydrocarbons means that they are molecules that contains carbon and hydrogen only. And then the last one, they say each member differ by 1 carbon and 2 hydrogen atom. This one you probably don't make sense to you at the moment. So let's come up with a list with 1 carbon alkane, 2 carbon alkane, 3 carbon alkane, 4 carbon alkane. So this is CH4. Then this is C2H6. C3H8 and C4 what H10, the first 4. Then I'm trying to explain this last sentence here. So what happened is you will notice number pattern. You plus a CH2, right? The difference between the second alkane and the first alkane is if you subtract off the atoms, right? You will see that there's 1 less carbon, 2 less hydrogen over here from the second carbon to the first carbon, right? From 2 carbon to 1 carbon, there's a missing CH2, right? Or you don't know what I'm saying?
No, don't know.
Don't know what I'm saying.
Yeah.
Are you okay with the formulas? The 1 carbon alkane, 2 carbon alkane, 3 carbon alkane, 4 carbon alkane.
Yeah.
Okay.
The general formula is that.
Yeah, you just use general formula, you smack the formula there, and then you will get that.
You can just
So
put the number of carbons in the end.
like that, right?
Yeah.
This is the 1 carbon alkane. Then we go to the 2 carbon alkane.
C2H6.
Then I draw this, right? Then 2 carbon. So what is the difference between the 2 carbon and 1 carbon? One extra this, right?
Yeah, 1 carbon and 2 hydrogen.
So 1 extra this, right? So the 1 carbon to 2 carbon, the difference is 1 carbon and 2 hydrogen, right?
Yeah.
So then I go to the third one. Third one is C3H8. Okay, so you compare the second and the third, the 2 carbon and the 3 carbon. So what's the difference between this and this?
Just one of this one.
So
the CH2.
So you have 1 extra group of these. Then from the 2 carbon to 3 carbon, they differ by 1 carbon and 2 hydrogen atoms again. This is what I mean. Okay?
Yeah.
Okay. So then now I explain this. Just now I told you to, keep that word in mind. It's a common question they'll ask, why is an X compound a saturated compound? So saturated means the molecule only contains carbon single bond. It means that. So saturated means the molecule only contains carbon single bond. So let's consider the 2 carbon. It is drawn in this manner. So do you know what the lines mean?
Means 1 line means 1 bond. Means they share 1 pair of electrons.
So it's like that.
Yeah.
So carbon has 4 electrons in the outermost shell. So the carbon, each carbon will covalently bond to 4 other atoms. So each carbon is covalently bonded to 4 other atoms. So that means all the electrons are taken already. So you cannot add any more atom to it. So this is what the second statement is saying. Okay?
Yeah.
They will ask you to draw the dot and cross diagram. So you have the examples here. So you have first, second, and third alkane. Then you get the molecular formula that you are already familiar with. The structural formula, I show you how to draw it already. Then you look at it, examine these 3 things. Examine this 2. Then this one, I also kind of taught you how to, from here, go back to this way already. Or the reverse is also true. So notice the boiling point, what happens? Does the boiling point increase when the number of carbon increase?
The boiling point decreases.
Decreases. When you increase the number of carbon, increases or decreases? I cannot
increases.
Yeah. So then that means when carbon increase, the boiling point increase. Okay. Then the boiling point is super low, so they are all gases at room temperature. This is an observation from this table, but I will elaborate on this later. So just now we talked about bonding in the alkane molecule. So these are 2 examples. So the dot and cross diagram, they will make you draw them. So how would you draw a propane molecule? So they will not tell if it's within like 1 to 5 number of carbons, right? They are unlikely to give you how many carbons are there. So that one you assume you know. They assume you know. So I can just throw propane and you will need to know that it contains 3 carbons. Looks okay. So this is assuming they only want the valence electrons, right?
Yeah.
Okay. Then this one talks about solubility in water. This is an extension of chemical bonding. So alkanes, they are considered simple covalent compounds. So they exist as simple covalent molecules. Then because they are covalent, they are insoluble in water and they are soluble in organic solvents. So you would see this in chemical bonding too. So when they quiz you on this, they can be testing from the chemical bonding perspective, or they can test you under alkanes, organic compounds. So in general, if there is a change in
viscosity.
Sorry?
What is viscosity?
Okay, so imagine water, then you tilt the water bottle, inside the water bottle there's a water, right? The water will just flow according to the movement of the bottle, right?
Yeah.
Okay, then you imagine liquid glue. You seen those transparent liquid glue?
No.
That comes in the bottle?
No.
Have you seen oil?
Yeah.
Oil, so then you have a bottle of oil, okay, transparent again. Then you tilt it, the oil will flow, right?
Yeah.
What's the difference between how the oil flow and how the water flow? Does the oil flow a little slower than water? Or you can run to the kitchen right now and compare. Do you know how the difference, how water flow and how oil flows?
It is slower than the water.
So the oil, right, is said to be more viscous.
When tilted to the side, it flows slower. That's viscous.
Yeah, so oil is more viscous. So when you increase the number of carbons in alkanes, in fact, alkenes also, so the boiling point will increase, the density will increase, the viscosity will increase, and the flammability will decrease. Flammability means how
it sets on fire.
Yeah, so that means if you have a 20 carbon alkane and a 5 carbon alkane, the 5 carbon alkane will be easier to set on fire than the 20 carbon alkane, right? So you have these few physical properties that will change according to the number of carbon. So they may ask why the melting boiling point of alkanes increase when the size increase. They will also ask why alkanes has a low melting boiling point. They can ask this from organic chem, under organic chem, or they can ask this under chemical bonding. Because if you notice, the reason is a chemical bonding reason. Familiar?
Yeah.
Okay. So alkanes have low melting and boiling point. So they are simple covalent molecules. Now methane will be like that, and molecule form will look like that, right? So it will form intermolecular forces of attraction between molecules. Then you can have other a longer alkane molecule, it will look like that. Then try draw another one here. That. So you can have intermolecular forces of attraction forming like that, like that, like that, with this, with this, with this, with this. So all these dots are intermolecular forces of attraction. IMFA. Intermolecular forces of attraction. Then intermolecular forces of attraction here. So compare the small molecules and the big molecules. Later you see. So first one, because in methane, right, there are intermolecular forces of attraction, but these are relatively little and they are weak. So they are held together by weak intermolecular forces of attraction. Then they can be overcome by small amounts of heat. So you have low melting and boiling point. If they ask for why alkanes have low melting boiling point, give them this, which is also very similar to why chlorine has low melting boiling point. The reason is about the same. Then the second part, they say the melting and boiling point increases as their molecular size increase. So that is where what I'm drawing here, the below diagram. So I have one which is low carbon, that means low molecular size, and then this one has higher molecular size. The one on the left is low, and then the one on the right is high. Okay. So because the molecular size increase, the forces of attraction between molecules, right, be stronger or larger. So more energy is required to separate the molecules because of this. Okay.
Yeah.
They ask for a reason, you give them that. So back to this. Okay, so we have this, right? Melting boiling point. So they have low melting boiling point. So the first four alkanes are gases. Then 5 to 17, right? Because their intermolecular forces of attraction increase due to their size. Their boiling point will increase, so they are liquids. And then from 18 carbon onwards, right, the alkanes are solids. You just need to know the melting boiling point increase. Okay? Okay?
Yeah.
So then density is basically the amount of carbon increase, the density will increase. So the reasoning, I don't think they will ask. But what happened is it's like this, because when it's low number of carbon, they are gases, so they are packed far away from each other. So the mass in a given volume is low. And you know density is equals to mass divided by volume. So low mass in a given volume means the density is low. So this is low number of carbon. Then if you have high number of carbon, the molecules will be closer together. So then the number of atoms or molecules per unit volume increases. So then density will increase because the mass increase. So they're packed closely together. So another way to explain it is because of the intermolecular forces of attraction. Because the forces of attraction increase, so particles become closer to each other. So when they become closer together, right, density is also a measure of how packed the atoms are together. So because it's more packed, so the density increase. You can also understand like that. But if it's too complicated, just remember this. Then liquid alkenes are less dense than water, so they will float on water. Okay. Then viscosity, the number of the more carbon there are, the more viscous it gets because of the intermolecular forces of attraction again. And because the molecules are long, they will tangle up. They'll overlap with each other, they will stick to each other, so the viscosity will increase. And then this one, big ones are less flammable because of high percentage of carbon. So they are more difficult to burn. Then if you burn these larger molecules, you get a sooty flame, a smoky flame. That means you see like got smoke like that coming out. So the smokier flame is because of incomplete combustion, which I will talk about later. Okay, so alkanes are unreactive. So they have very few chemical reactions. So the only chemical reactions you will have and you learn is these three: combustion, substitution, and cracking. Cracking, I will talk about it under alkenes in detail. So we are only going to talk about combustion and substitution in details here. Combustion is just, I mean, if you want to imagine, right, then it will be just you taking a piece of paper, then light it on fire, and then you start burning. That's combustion. That means you burn paper. Burn paper is combustion. Then if you burn oils, burn fuel, those are all combustion processes. Familiar with that?
Yeah.
So there are two types of combustion. One is complete combustion and the other one is incomplete combustion. Complete combustion means, right, alkanes will react with excess oxygen. Then the flame come out will be blue color. Then there isn't any smoke. So alkane plus oxygen gas will give you carbon dioxide and water. This one, in any complete combustion, the reaction, right, the product will be likely to be just this. So write a word equation and chemical equation for the combustion of ethane. How to write?
Right, the word of ethane is, so it's methane plus oxygen,
Ethane
right?
plus oxygen, yes.
Methane is
Ethane.
Ethane is
Then you go back to your previous slides. So ethane plus oxygen gives you a
carbon dioxide and water.
standard, huh? The product is always the same.
Okay.
Then now is balancing the equation.
Ethane is
How many carbon?
E is 2 carbon.
2 carbon. Then you have the general formula CnH2n plus 2.
So it's 6.
So it's C2H6.
C2H6.
What's the formula for oxygen?
O2.
O2. Then carbon dioxide.
CO2.
Then water.
H2O.
Okay, then balance.
Balance. 3H2O, right? 3.
I don't know.
Also go high.
You can balance first and then you let me know what you want to put as coefficients. If writing typing is difficult for you.
Oh, wow. You must use 6. 2C2, then 2 ethane,
Then
5 oxygen,
I just write down your answers.
4. You must change oxygen to 7 instead of 5. 4 CO2, then H2O is 6.
6.
Yeah, 6.
Okay, so C2H6 plus O2 gives CO2 plus water. What I usually do is I'll balance the carbon first. So I do this. Then after that, then you will see that there are 6 hydrogen, so I put a 3 here.
Yeah, but then the oxygen
got half, right? So you got four oxygen here and 3 here, so it's 7 oxygen.
Which is the odd numbers.
Yes, so become 7 over 2.
Yeah, so you must
yes.
times 2.
Then after that, I times 2 to everything.
Okay, did I miss one? Oh, I missed one carbon. No, correct.
So your answer is correct. Yeah, but I'm telling you, combustion question, organic chem question, usually we will go for the carbon first, then combustion, then we go for hydrogen, then we aim the oxygen last.
Okay.
So we will let you attempt the next one on your own, then you get back to me.
Okay. Okay, can.
So it will be propane plus oxygen gives you carbon dioxide and water. So this one is always the same. Then propane is carbon 3, so it's C3H6 plus 2, 8. So it's C
6 plus 8. Oh,
plus oxygen gives you carbon dioxide plus water.
Yeah.
Like that. Then follow, then balance the carbon. Then we got 4 here. Okay, so now you got 3 times 2, 6 plus 4, 10. So divide by 2. So this is easier.
Yeah, this one easier. The numbers are not too big.
So last section. So there's incomplete combustion. So incomplete combustion, the alkanes will burn with a yellow smoky flame. So you'll burn with yellow smoky flame. So your products are not confirmed. In incomplete combustion, you may get carbon monoxide, and water. You can get all of them or only 2 of them. So incomplete combustion usually happen to alkanes with a bigger size. So then when that happens, you see that you burn it, you get a lot of smoke coming out because incomplete combustion. So incomplete combustion for methane, what you get is you may get carbon monoxide plus water.
Okay.
You may also get soot plus water.
So it's just carbon. Okay.
Yes. So then you will balance accordingly. Then in exams, usually when there's incomplete combustion, they will hint the products. But if they never hint, most likely it's just carbon monoxide plus water.
Okay. Let's say they don't.
If they don't, then you assume it's carbon monoxide water.
Okay.
But usually they are indicative, they will tell you what it is. Explain why alkanes are not reactive. Mentioned just now.
Is it the ionic?
I mentioned there's saturated See, there was one slide, reactions of alkane, then I say they are not reactive because they are saturated. So
That means that they are
you only have carbon-carbon single bond.
okay.
Then all the valence electron is being shared with other atoms. Yeah. So what you say is they contain carbon-carbon single bonds. Then each carbon is covalently bonded to 4 other atoms. So then finally you say that because of that, no new atoms can be added to each carbon anymore. So it's not reactive. This one don't care. Done. What is an incomplete combustion?
It's when there is not enough oxygen.
Yeah. So it's burning of substance in an insufficient amount or supply of oxygen. Yeah. This one is for interest sake only. They will not ask for this definition.
Okay.
So name the possible products formed during incomplete combustion of alkanes. 3 things. What are the 3 products that may possibly happen, appear, be produced?
Soot, right?
Yep.
Carbon monoxide
Mm.
and water.